We're going to have our first video involving connecting a function and its derivative. So derivative connections. We've got a graph of a function. It's pretty weird looking, and you can certainly copy this down in your notes. And this is the graph of f, and we see that the graph is increasing, then it flattens out for a moment, and then it continues to increase again. It has a max at the y-axis, and then a min down here on the x-axis, another relative max at this cusp, another min down here, and then the function increases again. So I'd like to go back to the song for a moment. Remember, the derivative is the slope of the tangent to the curve at a point along the way. Hey, so we've got ourselves a lot of points on this curve. And so what I would like you to do right now is pause the video. You'll see, actually not yet, quite yet. What I'm going to do is I'm going to draw some tangent lines at any particular point. So I'll draw a tangent line right there, and we can draw another tangent line right there, and another tangent line right here. So please pause the video and draw a whole bunch of tangent lines on your paper, and I will do the same. Okay, so we're back. Hopefully you have a bunch of tangent lines on your graph like I now have. Okay, so the derivative is the slope of the tangent lines. So let's check out the slope of all the lines that you've just drawn. Specifically, let's check out the slopes of the tangent lines when f is increasing. So we know that f is increasing all the way until we get up to this relative max right here. Let's look at these 1, 2, well, we'll skip that one for a second. 1, 2, 3 tangent lines. If we look at the slopes of these 3 tangent lines, are they positive, negative, 0, or undefined? Exactly, they're all positive. 1, 2, 3. These 3 slopes are positive. Well, the function's increasing again right in this little area. And lo and behold, we have another tangent line, and the slope of that tangent line will also be a positive number. The exact number we don't know, but we do know that the number will be positive, as will the slopes of these 2 tangent lines, which is once again when our function is increasing. So we have clear proof in these 6 instances that the slope of the tangent line will be positive when the function is increasing. But the derivative is the slope of the tangent line. So therefore, by the transitive property, when a function is increasing, the derivative is positive, because the slopes are positive and the derivative is the slope of these tangent lines. Let's check out when f is decreasing. Okay, when f is decreasing, well, decreasing in this little section right here, and we have 1, 2 tangent lines, which are certainly negative with their slopes, as is this tangent line right here, in another case, another quick little interval in which the function is decreasing. So when the function is decreasing, the derivative is negative. These 2 facts are going to be extremely important, not only for the rest of this month, but for your success on the AP exam and this course in general. We need to know and understand that when a function is increasing, the function's derivative is positive, and vice versa. And when the function is decreasing, the function's derivative is negative. How about when f has a relative max? Well, f has a relative max right here. That's the top of the hill. And we got another top of the mountain right there. Well, the slope is 0 here. The slope doesn't exist right there. We talked about that earlier in the year. A cusp is when one of the three times when a derivative does not exist. Okay, so let's look at what happens with the slopes changing. Well, before this max, the slope was positive, and afterwards, the slope was negative. Before this max, the slope was positive, and after the max, the slope was negative. So if f has a relative max, that means that the slope changed from positive to negative. In other words, the derivative changes from positive, I'm going to do a little plus with a circle around it, for positive to negative. We also have two mins, here and here. Well, before the mins, the slopes were negative, and after the mins, the slopes are positive. So we can say that f has a relative min when f prime changes from negative to positive. One more term to discuss. When f has a critical point. Okay? F has a critical point when the derivative is equal to 0, because remember, first of all, I should define a critical point. A critical point is where a relative max or a relative min could occur. Doesn't mean it will occur, but it could occur. And a critical point is going to be in the remaining times when f prime is neither positive or negative. Remember, the derivative is the slope. We talked about positive slopes and negative slopes. What were the other two types of slopes you learned about a long, long time ago? Yeah, zero slope and no slope, undefined slope. Well, here's a case where we have zero slope. Here's a case where we have zero slope. And these two cases are where we have zero slopes. Sometimes the zero slope produces a min. Sometimes it produces a max. Sometimes it produces neither. At the same time, we can also have a max where there is no slope. All of these points right here are known as critical points. Critical points are where the derivative equals 0 or does not exist.